Let's explore Chapter 10, Review Exercise 2, entitled A Smash or a Hit. Two researchers asked 150 subjects to recall the details of a car accident they watched on a video. 50 subjects were selected at random and asked about how fast were the cars going when they smashed into each other. For another 50 randomly selected subjects, the words smashed into were replaced with hit. The remaining 50 subjects, the control group, were not asked to estimate a speed. A week later, all subjects were asked if they saw any broken glass at the accident. There wasn't actually any, but they were asked if there was. The table shows each group's response to the broken glass question. So if they said smashed into, 16 of those 50 said there was glass when really there wasn't, and 34 of them correctly identified that there was no glass. For those who were asked how fast the cars were going when they hit, 7 of them said that there was glass at the scene, 43 said there were not, and for the ones that were not asked to estimate speed, 6 said that there was glass at the scene and 44 said that there was not. In Part A of this problem, we're asked to state the null and alternative hypothesis for a test to determine if there's an association between the type of question and response for subjects like these. The null hypothesis is that there's not an association between question type and the type of response that we would get about the glass. The alternative hypothesis is that there is an association between the question type and the response about the glass for subjects like these. There's no significance level stated, so we're going to just pick one, and we can say that alpha equals 0.05. In Part B of this problem, we're asked to calculate the expected counts for the test that we're going to perform. So this is the table again of the actual counts. The expected counts are calculated by doing this, multiplying the row total of 29 times the column total of 50 divided by the grand total of 150 total participants for each of the cells. We're going to do this across all 6 of the cells that we have. And those become 9.67 and 40.33. Checking the conditions for the test is what we're asked to do in Part C. There are 2 conditions. The first is that this was random, or there was some element of randomness. In this case, the treatments were assigned at random to the 150 subjects. Each of the subjects was randomly placed into one of the 3 treatment groups. And in terms of large counts, we just calculated what the expected counts were in Part B, and we saw that they were either 9.67 or 40.33. Both of those are at least 5, and so we can continue with our test. In Part D of this problem, we're asked to calculate the test statistic, which is going to be chi-squared, and p-value for the test, and make a conclusion. So our chi-square statistic is calculated this way, using the observed counts and expected counts from the 2 tables that we have. And we do it this way for all 6 of the cells. The first cell had an actual value of 16 in it and an expected count of 9.67. We're going to apply this formula of observed minus expected squared over expected and add them all up to get chi-squared equals 7.78. The degrees of freedom here is going to be the number of rows in the table minus 1 times the number of columns in the table minus 1. Our table had 2 rows and 3 columns, 2 degrees of freedom total. And using table C, our chi-square table, we can find that the probability that chi-square exceeds 7.78 is some number between 0.01 and 0.025. We can also use technology using the applet from our textbook or from our calculator using chi-square CDF to give us a p-value of 0.02, which is in this range anyway. Our conclusion is that since the p-value is low, below 0.05, any number in this range would be below 0.05, we're going to reject the null hypothesis and conclude that there is an association between the type of question and the response that we would get for subjects like these.